This is one of the coolest systems we have. It's called a biopod. Because of the biopod, we don't have to rely on store-bought chicken feed. We first build a ramp out of coffee grounds. The free used coffee grounds are coming from local coffee shops. We then stack cardboard together, connect it, and let it hang from the top. We then can add in leftover bones, dairy products, and vegetable scraps. The smell of all the food and coffee attracts black soldier flies. They enter through the top, where we have these PVC pipe openings. They then lay on average 700 eggs in the cardboard, because the cardboard has lots of nooks and crannies, which is the perfect environment for them to lay eggs. The eggs then hatch into larvae, and they find their way into the coffee grounds and eat the organic matter. When the larvae are ready to turn into their fly form, they'll start to move upward, searching for soil, because they know that they're in a food source, not soil, and it's soil that they'll have to stay in for about a month until they can turn into flies. As they move upwards, they fall into the bucket, which means they self-harvest themselves for us. Chickens need leafy greens, grains, and protein. We can grow the other two, and now we can also grow the protein. This is a methane digester, and it's my favorite system here at our land lab. It gives us 2 hours of cooking fuel a day and gives us liquid fertilizer, and we no longer have to rely on store-bought gas. We first start by filling it up with 1,200 liters, or 317 gallons, of water. We then add cow manure, which gives it anaerobic bacteria. Once the initial setup is done, we then add 1.5 gallons of food scraps a day. That can be anything from vegetable scraps to bones. The best input, though, are starches. The bacteria then breaks down all the organic matter that we put inside of it. This creates natural methane. The methane collects in the top bag, but first it goes through a carbon filter, which takes care of the odor. To pressurize the methane gas, sandbags are built into the system to weigh it down. We can now turn a valve on, which will send the methane to our cooktop stove. The 1.5 gallons of organic waste gives us 2 hours of cooking fuel a day. Everything else that's not turned into methane is turned into liquid fertilizer, which we give to our plants. This system helps prevent 6 tons of CO2 emissions a year. These are the essential 5 components you need to live off the land. First, you need water. We get ours from our rainwater collecting system. The second thing you need is a good food source. You can grow so much of what your diet needs. We also have chickens, which give us eggs for good protein. The third thing you need is shelter. We went with a tiny house, but you can also use a tent. The fourth thing you need is sanitation. This right here is an outdoor composting toilet. You can even pump the water you need. Sanitation also comes in the form of this, our methane digester. The last thing you need is energy. We use solar panels for this. This will give power to your tiny house or your tent. This is a worm tower. It gives us infinite worms and gives us incredible compost. To make one, you'll need 3 5-gallon buckets. Make sure they're food grade. One of the buckets needs to have a solid bottom and the other 2 need to have holes cut out. You'll stack all 3 buckets together, ensuring the top 2 are the ones with the holes cut out in the bottom. You'll seal the middle bucket's holes with newspaper. Then you'll add in the organic matter that will be turned into compost. We'll be using unbleached paper, a 1/4 gallon of water, old cool compost, old tea bags, cut up cardboard, and finally tea and coffee grounds with some baked crushed eggshell, as these 3 items provide the worms with grit to help break down the food in their stomachs. Once thoroughly mixed, you can add in your worms, which you can get from a worm farmer. We'll also add in some peaches and shredded cabbage and carrot. Over the next 3 to 6 months, the worms will break down the organic matter into compost, and their population size will double every 90 days. When all the organic matter has been broken down, the worms will go through the holes in the bottom of the bucket above them because we just put in new organic matter. We then can extract the compost from the middle bucket and then put it on top and put new compost on top of that, repeating the process. To make sure nothing else gets inside, we put a mesh on top before we put the lid on, and then we store it in a cool place so the worms are happy. Since the ideal temperature for worms is 55 to 75 degrees Fahrenheit, although they can survive from 40 to 95 degrees Fahrenheit.